Well, one of the common questions you find in a simple harmonic motion problem is to find the phase constant to fit into the equation. Ironically, this is one of the more time-consuming parts for a lot of students, and yet it's probably the least important value in the entire equation. But I'm going to try to provide a little supplement to what's in the textbook that will help you quickly find what this phase constant should be. Okay, so you could be given a number of different situations here to find the phase constant. One would be to be given a plot of the simple harmonic oscillator, its position versus time graph, and that's like one I've shown you here. I just grabbed a nice cosine curve off the internet just because it was better than anything I could draw. You could also describe the initial conditions just in words, but at any rate what you want to know is what is the position of the object at the very beginning when the clock begins at time equals 0? Because if you know that and you know what the amplitude is, as I can see here from any of my graphs, then I can put those values into the equation for the position and see what the phase constant comes out to be. So if I use, for example, either the red or the green graph, those are two possible graphs that you could have for an oscillator, and either one, you notice at time equals 0, I'll put a little mark here, that's the position that it's at. So that's about 0.7 or so on the vertical axis. So what I would do is I would put in about 0.7, and then the maximum position for the entire graph is at 1, and that occurs at time equals 0. So that's the cosine of 0 plus our phase constant. Of course, I don't really need the 0 in there. So if I just do a little bit of algebra, I would say 0.7 is equal to the cosine of the phase constant I'm looking for. Now, if you ask your calculator for the solution to this, it's going to give you just 1. Depends on whether you're in degree mode or radian mode, but we'll assume, let's say we're in radian mode, and it's going to give us a positive pi over 4. It will give you maybe the decimal version of that depending on the mode that your calculator is in, but I'm going to use the exact form here. The problem is that that is one of just many different values that has a cosine equal to 0.7. And let me show you some other ones. Now I'm going to look at the blue graph, because the blue graph is actually the pure cosine function. So we can see on the blue graph, and I'll mark some spots in purple here, places where the cosine is equal to 0.7. Here's a spot right there. There's a spot way over here on the right. Here's a spot right here. And there is actually infinitely many more. So the question is, well, which one do we want? And the answer is it depends. Usually the phase constant is a number between negative pi, so like here's the boundary on the left, and positive pi. That would be negative 180 to positive 180 in degrees. And so you will restrict our choices to that. So then what you have to look at is, well, do we have a graph that shows a cosine curve shifted a little to the left or to the right? So in the case of the green graph, if you compare it to the original cosine curve, which is in blue, it's been shifted just a little bit to the left. And I've shown that here with the green arrow pointed leftward. So anytime you have a little shift to the left, that means your phase constant is going to be a positive number. And then in red, like you see the red graph there, just shifted a little bit to the right compared to the blue one, that means we have a negative phase shift. Now in the case here, our phase shift is either positive or negative 0.4, depending on whether it's the red or the green graph. If we had a different value, for example, maybe instead of 0.7, we had a starting point at like 0.5, then that would be a positive or a negative pi over 3. That's an example from Dr. Knight's textbook. And there's any number of values that we could get. So the question that you need to answer is, has this been shifted up to a half a cycle to the left which means a positive phase shift, or half a cycle to the right, which means a negative. And that'll tell you which of the two values is appropriate for your particular plot. So I hope between this and some other sources you might find it gives a little clarity on how to pick that. I will tell you this is not something to sweat over, because as far as the AP goes, it is not something that is really a concern at all there. Just a few questions to get through some of the homework. So we'll take it at that and not sweat it too much. All right, so good luck with that, and if you have any more questions, hopefully you can find me for some help.